Welcome back, and welcome to the Measure module. The Greenbelt math starts now, and it starts with 4 numbers: mean, median, variance, and standard deviation. Here's the hook. An average can lie to you, and both exams test whether you know when. Today, we compute everything by hand on real cycle time data, then I'll run the same numbers in the LeanProjax platform to check our work. Let's measure. First, where is the center? The mean is the balance point. Add every value, divide by the count. The median is the middle value once the data is sorted, half above, half below. The mode is simply the most frequent value. Here's what the exam actually tests. The mean chases outliers, the median doesn't. Add one machine jam to a week of normal cycle times and the mean jumps. The median barely moves. That's why house prices report the median. Rule of thumb, skewed data or outliers, report the median, symmetric data, the mean is fine. Center is half the story. Spread is the other half, and spread is what 6 sigma is named after. Range, maximum minus minimum. Quick, but one outlier owns it. Variance, take each value's distance from the mean, square it, add them up, and divide by n-1. Squaring kills the minus signs and punishes big misses. Standard deviation is just the square root of variance, back in the original units, seconds not seconds squared. And the exam trap, divide by n-1 for a sample. Plain n only when you truly have the whole population. Samples underestimate spread, n-1 corrects for it. Worked example, by hand. 5 cycle times from line A in seconds. 41, 44, 45, 49, 51. Step 1, the mean. They sum to 230, divided by 5, 46. Step 2, the median, already sorted. The middle value is 45. Step 3, deviations from the mean, -5, -2, -1, +3, +5. Square them, 25, 4, 1, 9, 25, they sum to 64. Divide by n-1, 4, and the variance is 16. Square root, the standard deviation is exactly 4 seconds. Range, 10. That's the whole toolkit on one slide. Now let's check our work. I'll use the LeanProjax platform. This is the data playground. I'm uploading a file with exactly our 5 cycle times. The moment it lands, the profile reads the column. Minimum 41, maximum 51, mean 46. Perfect so far. Now the SQL Studio. One query asking for the count, the mean, the median, and the sample standard deviation. Run it. 5 observations, mean 46, median 45, standard deviation 4. Every hand calculation confirmed. And the same query on 50,000 real measurements takes about a second. Mean 45.67, standard deviation 5.62. Same discipline, any scale. So what do the numbers mean on the job? Mean above the median, a long right tail, slow outliers are dragging the average up. Standard deviation is the ruler of this whole methodology. Process width is measured in sigmas, and specification limits sit a number of sigmas from the mean. That's the sigma level from lesson 0. One vocabulary pair before the drill. Describing the data you have is descriptive statistics. Using a sample to make claims about the whole process is inferential. That's where the analyze phase lives. Measure describes, analyze infers. Exam drill. 2 questions. Question 1. A data entry error adds 1 cycle time of 900 seconds to a normal week. What happens to the mean and what happens to the median? Pause here if you need a moment. The mean jumps toward the outlier. The median barely moves. One value shifts the sorted middle by at most 1 position. Question 2. You compute variance dividing by n on a sample of 25 parts. What did you just do wrong? Take a few seconds. You treated a sample as a population. Dividing by n underestimates the true spread. The sample formula uses n-1. 4 numbers, 1 worked example, and the platform agrees with your pencil. Add the mean, median, and n-1 variance to your formula sheet. They anchor half the measure questions. Next lesson, probability distributions. normal, binomial, and Poisson, and when each one shows up on the exam. Subscribe and I'll see you there.